Lesson 59, which is the histogram. Histograms. We will be able to construct and draw histograms. Now, this is going to be something you're going to have to draw along with me as we go through this lesson. But we're going to talk about, well, why do we care about the histogram? What is histogram? Today's fact is Leonard Euler discovered that in that 63,531,865 is equal to 59 to the fourth power plus 158 to the fourth power. There's where the 59 comes in. Or you can actually represent it as 133 to the fourth power plus 134 to the fourth power. And what that means, well, why is that cool? Because it's the sum of two powers of 4 in two different ways. So you found a way, that number is the sum of the two powers of 4 in two different ways, which is, I find that pretty impressive, level, full stop. But some of you guys will be like, so what? The more impressive part about this fact, I always like to draw attention to people, is that Leonard Euler discovered this with pen and paper in the 1700s. So he went through the powers of 4 and would calculate these powers of 4 by like on pen and paper, and then found that it just so happened these 4 powers of 4, these two pairs add up to the same number. And it's just a bit amazing and impressive. And it's just like, yeah, sure, like we could computer program a program to calculate, powers of 4 like this. It'll probably take us maybe half an hour to make a program and maybe 5 minutes to run the program, but it would have taken him with pen and paper doing this by himself a very long time. So it's just an impressive sort of feat to show that, you don't need to have computers to do, sophisticated maths calculations. And one of the things that mathematicians look at is computers are a tool, not necessarily the mathematician. So before we get into histograms, let me just double check what we did last lesson. Last lesson, what we did was we did reporting on data. Reporting on data was like looking at our frequency tables and learning how to turn these frequency tables into massive slabs of text, which actually sounds really kind of pointless. But the reason that we do that is because not everyone can interpret these things on their own. Sometimes you need to give people, you need to analyze them for them. And we did that. Well, I showed you guys some shortcuts, and then we did an example. We actually did this big example here. We looked at aliens. We said, well, how many people agreed, disagreed, so on and so forth. And then I gave you 2C to work on. 2C, in my opinion, is one of the easiest exercises that you guys are probably given in year 11, but probably not the easiest. I reckon probably some of those arithmetic ones. But, it still was a pretty easy one. We actually looked at an example from an actual set of data, and we even tried to interpret it ourselves. Well, we didn't actually do this. We didn't actually interpret it ourselves, but we just sort of looked at it. We just sort of said, well, what kind of things did they talk about? And then I said, work on 2C, questions 1 to 4, and that was it. And I've already given you guys a checklist if you don't already know. So what we're going to move on to now is histograms. Now, histograms are, in my opinion, maybe they're one of the next steps up when it comes to looking at data. A histogram is a great way to look at continuous data. It's a good way for us to sort of explain trends and what's going on. I prefer, to be honest with you guys, the scatter plot, because you can do a lot more with a scatter plot. But histograms are like a scatter plot, but for one variable. And because we're talking about univariate data, that's why we talk about histograms, not scatter plots. Let's talk about what a histogram is. Histograms are used for continuous data or measured data usually. All the data is put into separate class intervals. Remember what a class interval is like when we're doing something like between 50 and 60, and then between 60 and 70. That is a class interval. It's a group of values. A histogram is like a column graph, but showing the frequency of each interval, not showing the frequency of each value. And so the labels are put, and this is, I mean, I've seen some contradictory graphs that are called histograms, but ultimately this is my opinion of what makes a histogram. The labels aren't under the columns, but they're under the divisions, and the columns are joined together. So these are the two things. Firstly, if you have a look at this histogram on the right, what do I mean by that? Notice how if I look underneath this column, there's actually nothing there. There's actually nothing indicating what that column represents. The only way for me to figure out what this column represents is not to look directly under it, but to look where this column is between. This column is between 60 and 65. So that means this column represents the height in feet of trees that are, how many trees are between 60 and 65 feet, you know? And there are 3 trees that are between 60 and 65 feet. If I look at this column here is the amount of trees between 65 and 70 feet. Now, I can't look directly underneath, I have to look at these side lengths. Now, the other important factor here is to look at this. That 65 line has been used for both this and this. It is a dividing line. And it's not actually like a column, it's not the edge of a column, it's more of a dividing line. It's a lot clearer when you look at something like this part of the graph up here, where the dividing line forms the division between 2 different sections. And so that's what I think. And I've seen histograms that people are like, this is a histogram, even though it doesn't have the it's not the same. It doesn't have the lines between them. This also shows you why it's so important that all these columns are joined together, because they both, this one on the left and this one on the right, both need to reach to that 65 line. I have seen some histograms that have more defined columns. I don't think they're histograms, but you know, they can claim whatever they want. I'm going to keep this slide up from, you don't need to copy the image down because we're going to create our own one actually, but I'm going to change the slide in about 30 seconds from now. So if you are copying this down, which you should be because it's a pencil, I'm going to give you guys another 30 seconds, but then I'm going to jump ahead. I think I've given you guys access to this PowerPoint as well. If I haven't given it to you, please let me know and I'll make sure that you've got it. So the best way for us to understand histograms, there's a question here in chat, I assume. No, you don't need to copy it. I said, don't worry, we're going to do our own one. The best way, in my opinion, to understand histograms is to create our own histogram. So how we're going to do that using this example here. Now, there's no pencil here, so we're not going to copy this down, but I'm going to take you guys through the full steps. We're going to take this data, we're going to put it into a tally, and then what I am going to get you copied down is how to turn this tally into this histogram that we're going to create. But we're going to build on that. So first we're going to do this part here. Now, filling up a histogram, first we've got our class intervals. Our class intervals are from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. And then what we're going to do is we've got all of this data. So we're going to put this data into our tally. I'm going to try and do this as quickly as possible. But you know, you would just make your way down the list and add them to the list on the right as a tally point. Something that I'm going to draw your attention to is you'll notice that as I do this I am crossing I'm crossing the value off on the right. The reason I'm doing that is because I don't want to double count something. That's probably the easiest way to make a mistake, is to double count something. Now, in a test, you would be able to do this as well yourself. And I would strongly suggest you do that. You would be able to cross these off. Now, it's unlikely that you'll receive a question with this many data points in it, because it would just take you guys too long to do. But, you know, it's still something that you could do. It's still something you could get. So, you know, just be prepared for it. Just be aware of how you need to do it. Maybe do one question on this kind of thing, just so you know, okay, so this is how I would do it. All right. You can also see why, ladies and gents, why I'm not getting you guys to copy this step down, because this step would take a long time for you guys to first copy down and then 2 to do yourself. 7 is at the top, 15, 37, oh man, running out of space, 49, beautiful. Okay, that's everything. So that took a bit longer than I wanted to, but you know, we got there. So now we count frequencies. So we've got 5, 6, 10, 11, 8. Oh, geez, almost said 3. 8 and 3. Adding all these up, by the way, this might be useful for us to do later on. Let's do this, but we'll add them up now. 5 plus 6 makes 11, plus 10 makes 21, plus 11 makes 32, plus 8 makes 40, 43 is what I get as a total. Let me check. There is 1, 2, 3, 4, 5, 6, 7, 8, 9. And they've got 9, 18, 27, 36. Whoops. God damn it. Yep, cool. 43. I got 8 in this column plus 8 in this column, so 16. So that's how I got 27 plus 16. Cool. So these, I'm now going to transfer all of these over to here. 5, 6, 10, 11, 8, 3. 5, 6, 10, 11, 8, 3. With the total being 43. What I'd like you guys to do first, and I might even give you guys a fraction of a second to do this, is could I get you to copy down this first and then get yourself a graph that you can start drawing on. If you are doing this on paper, which you guys should be doing, I'd recommend that bottom line be 1, 2, 3, 4, 5, a little, maybe 7 centimeters across or so, maybe 6 centimeters, 6, 7 centimeters across. And the vertical line, maybe you don't want as much, so maybe just 6 centimeters. Up to you though. But yeah, I'm going to give you guys a generous minute to get that into your books so that we can start creating a histogram. So I think the word gram means picture. So histo means like a historical picture. Histo, I think, means, I don't know. You know what? I don't actually know. My guess would be history, like histography. I think it would be something like analysis or maybe reflection. But yeah, it's like a reflection picture. That's where Instagram is like an instant picture. That's why it's called Instagram and stuff like that. Now, why is it called a histogram and not a histograph? A graph is like a drawing. I don't know. I don't know. I think it would be technically a graph. But yeah, I'm not sure. I said I'm not. I don't know the etymology, which means I don't know how to break this word down. But that would be my guess. And of course, my guess isn't necessarily perfect. So what I'm going to get you guys to do is this. We've got 1, 2, 3, 4, 5, 6 intervals. So what you guys are going to need to do is you guys are going to have to do intervals of 6 along the bottom. If I was to do this for here, I would go 1 here, 1 here, 1 there, 1, oops, there, 1 there. My line, by the way, in real life, for me, I'm measuring this on my board. This is actually 9 centimeters across. So I've done a line every 1.5 centimeters. And then I'm going to go, so, and that's because I've got 6 divisions. Now, vertically though, I've got the maximum frequency about 12, about 11. If I round 11 up to the next even number, I've got 12. So I'm going to do like this. I'm going to go up every centimeter. Then what I'm going to do is I'm going to start putting in some values here. This is a frequency, and this is our, and then these down the bottom is our class intervals. So we're going to start, our bottom class interval is 0. Then we've got from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. Now it doesn't matter that I got a bit extra because, you know, if you have an extra centimeter at the end, that's okay. On the left, I'm going to go up by 2, 4, 6, 8, 10, 12. I broke these into 2 centimeter gaps because I had 6 centimeters here, and I want to go up to about 12-ish. If you went up by 1 centimeter, you would need 12 centimeters to do this whole thing, which would be a bit large. And if you went up by 5, 10, 15, then you're already at the answer in about 3 centimeters. So I go up by 2s. That's how I just draw a graph here. And we also want our graph to take up a large amount of space. I actually haven't noticed many of you guys make this mistake, so I'm actually really quite happy with you guys for that. But just for the record, you want to try and take up space in graphs. I've actually seen some examiners of year 12 maths, and they will actually say, well, you actually lose a mark because instead of we gave you this massive space and you did your graph like in the bottom third of it. Change your scale. Instead of going from 10, 20, 30, go instead by 2, 4, 6, and then that will make your graph be a lot larger. And that occurs in the sciences as well. That occurs in physics and chemistry and biology as well. You need to make sure your graphs take up a lot of space. If you're like cramming them into a small section, then you're probably not going to get your full marks. So now that we've got our graph set up, the next step is going to be, I'm going to change color, I'm going to go to a lighter blue, is to now start to put our lines in. So between 0 and 10, we've got 5 values. There are 5 values that occur between 0 and 10. Those 5 values range, right? We've got a 3, we had a 0, we had a 2, we had a 7. So all of those values are between 0 and 10. So how do we do this? What we do is we draw a line from this 0 line across to the 10 line and like that. And at this point here, you've got a couple of choices here. You could go straight down from that line, or you could leave it and then do the next one and then go straight down. Let's go straight down. Let's do that. Just because I can't be bothered figuring this out, I'm just gonna go straight down like this. And that, oopsies, where'd it go? I'm gonna shade that in. And there's that first line. Now you notice that that means that all the values between, there are 5 values between 0 and 10. Notice that we don't care, we're not writing 0 to 10 underneath. We're doing this for the borderline. For the next one, 6 values between 10 and 20. So between 10 and 20, we've got 6. So this is 1 up. So we're going to go from 6, which the 6 point would be here, to the 6 point on the 20 line, which should be about there. So how do we draw that line? We're going to draw a straight line across. And then we notice that now it's hovering in the air. So I'm going to join this to the 10 line, like so. And then I'm going to draw a line down from here, and I'm going to shade that in. That gives us our next line between 10 and 20. Now the next one along we're going to do is we're going to do the 20 to 30 line, which has got 10 in it. And now I'm going to start going a little bit faster. Might even start just, stop necessarily narrating everything. And you guys, of course, you guys can start doing this on your own. 10 to 20. Then we've got 11 between 30 and 40. 11's about there. So 11 between 30 and 40. Whoopsies, come on. Then we've got 8 between 40 and 50. So here's the 8 line. We'll go across. We'll go down. And then lastly, finishing off 3 between 50 and 60. So 3 between 50 and 60. At this point, then I would stop and I double check that it's labeled and everything. And I double check that I label the axes. In this case, I don't know what we're measuring here, so I can't really put a title down here. But you what's to say it's the I don't know. Maybe this is like the age of well, that would be like, let's just say that these are ages in years, and let's just say this is like the age of people at a supermarket, for example, something like that. I don't know, whatever your measurement is. But this is how you create a histogram, and I think that some of these parts are really, really important here. Let's go back to the start of the question. Was we took a bunch of these values and we turned those values into a tally, into a frequency chart. Remember, that's what this is called, a frequency table. And from that frequency table, we then use that to create a histogram. Now, the reason we prefer histograms in maths is because, and we're about to talk about this in the next slide, is you can actually get a fair bit of information from this. I can see visually from looking at this histogram, I can see, well, it looks like a lot of people are between 30 and 40 years old. A lot of them are going to be around that region. In fact, most of the people are in the middle of this graph. Most of them are, between 20 and 50, and they're closer to the middle. With it, like, you can almost tell that the mean of this data, the average value, is probably 32, 33 or something. You can see that as we move out towards the edges of the data, down here and here, that these values are less popular. They occur less frequently. So you're less likely to get a number between 0 and 10 and 50 and 60. And so we can get an idea of almost what you would refer to as almost like the shape of this graph. We can sort of tell the shape of this graph by looking at it. So what do we do when it comes to analyzing graphs like this? What do we do when we want to analyze a histogram? how can we do that in a mathematical way, and what does that mean? Well, let me show you. I'm going to change the slide now, unless someone says, do you guys need a little bit more time on this slide? Someone said something. Nope. Okay, let's keep going then. So we're going to talk about how we analyze the graphs here. So firstly, we're going to talk about is skewness. Now, skewness is essentially what the shape of a graph is. So a skewness is a symmetrical graph is easy to climb on both sides. You can imagine that if you were a person on this side of the graph, then you would find it just as easy to climb up this way as this way. Symmetrical means that essentially you have a line down the middle here. Let me draw this in. Let me draw a straight line. Let me draw a little bit straighter line. And you're saying this side on the left is very similar to the side on the right. Now, straight away, whenever I show students this, they say, oh, sir, this graph isn't symmetrical. Look at this section here. That's way larger than this bar here. And I would say, yes, I would agree. But the idea is not necessarily for a graph to be called symmetrical. Doesn't mean it needs to be identically symmetric. It doesn't need to be 100% symmetric. It just has to look roughly the same. As you go this way, the numbers go down. As you go this way, the numbers go down. And they both end at the similar sort of distance from the center. And that's how we measure a symmetrical graph. And so it doesn't have to be exactly symmetrical. That's one of the key ideas here. So going back to our graph that I just showed you before, this would be, in my opinion, a symmetrical graph. Now you might say, well, but look at this, again, the same thing you could say. What about this here? This is a much larger than this here. And I would say, yes, I agree. But in general, you can see that this side's going down and this side's going down, and they're close to the same rate. Yes, for example, this is 5 and this is 3, but they're both within the same neighborhood. Where you might see something that is not symmetrical is if you took something that is positively skewed. Now, positively skewed graphs have more values in the positive, and it's easier to climb from the positive area. And that's one way I would think about it. If I was a person and I was standing here, I would say to myself, wow, this is going to be pretty easy to climb. Whereas if I was standing here, and I'm looking at this sheer cliff face, I'm going to be like, oh my God, like this is going to be not a happy time to try and climb this. Now, in mathematical terms, what does that mean? That means there are more values in the positive area, which means that, you can see that there are a lot of values at 5. But then if you compare that, all these other values are spread out. It's almost like someone's taken a regular graph, like a regular symmetrical graph, and instead they pulled it this way. They pulled the values, so there are more those normal values which would normally stack up here have been stretched out onto the right-hand side. And that's actually sort of what mathematically is happening. When you look at these graphs, is that you actually see the numbers have been essentially skewed. They've been moved to the right. And so you might say, well, what's the physical ramifications? What's the real world idea of this? Well, this might be like, oh, if you look at results, if you look at I don't know, something like the house prices in like an expensive suburb, or maybe not, like maybe look at something like, I don't know, the price of coffee in an expensive suburb. That's going to be stretched to that's going to be positively skewed. There's going to be more expensive prices out in an expensive suburb than in a normal suburb. So it's going to be spread out. And there are reasons why the data can sometimes be positively skewed. So yeah, a positively skewed graph means there's more values in the positive. It's easier to climb from the positive direction. Now, of course, you guys can probably predict what's going to happen. If there is positively skewed data, then there's probably going to be negatively skewed data. And there is. Negatively skewed data is in the opposite. Negatively skewed data, there are more values in the negative, which means that it's easier to climb in the negative compared to the positive, because of course the positive is going to be harder to go up. But that's of course just looking at how the graph is. And honestly, the reason why I'm writing this down is because it's easier. It's a quick and easy way for me to describe it, so that if you guys ever see like a shape that looks like this, you guys can be like, oh, okay, that's negatively skewed. Now, this might be, of course, the opposite. This might be the crime statistics in suburbs in the West. And so you might notice that, oh man, there's more crimes happening in the West. You're more likely to get a crime. You're more likely to get less crimes or something like that in the West. So that's the difference, and that's what makes something negatively skewed. Again, the data is going to be shifted. And that's because you might expect it to be normal data, but maybe probability plays a role. Maybe there's a hidden variable that we don't understand that plays a role that can skew the data and make the data not look what it should look like. So these are the two types. I'm now going to try to sort of talk about and give you guys what you should look at when you look at it. Let me hold on a sec. Okay, fine. Let's just now go to look at, pardon me. I'm actually just going to go to here, which is now using the Zoom client to do this, but I just want to quickly show you the comparison. So you've got 3 graphs, right? Because I also want you guys to include a picture of this as you go, because you guys are going to have to be able to look at something and say, well, what is it? So we're going to have the first one here. This is called a symmetrical graph. A symmetrical histogram, and that's where you expect, the same amount of numbers in the negative and the positive, they should be balancing out. The opposite, of course, the next one we're going to do is going to be a positively skewed graph, which means that there is more values over the positive. And how I usually think about it, it's easier to climb. And the other one from the positive, and the last one is going to be a negatively skewed one, which is going to look like this. Oops. So yeah, negatively skewed. Which means there are more values over the negative, or small side. And this is going to be easier to climb from the negative. And it's just a different way to sort of, I guess, think about this sort of stuff. This here is not a great picture of it, but yeah, when you look at data, I want you guys to be a little bit confident about how to deal with this sort of stuff. And there are real world situations that cause things to be positively skewed and negatively skewed. Unfortunately, I can't think of any straight off the top of my head, and I don't want to get them wrong. I don't want to give you something and say, this is a positively skewed, and it turns out that I'm wrong. So I will get back to you guys on Friday with some decent examples. But what I want to do now I'm going to give you guys maybe another 30 seconds to jot this down if you haven't got this down already. Just like, you don't have to write these words down because you've already got them. What I'm really interested in you guys getting is these pictures. And these pictures, I just want you to be just in general, just a general picture. It doesn't have to be precise. It doesn't have to look, you know, as you can tell with these pictures, they're not super duper accurate. They're just a general idea of what's going on. I used to have all three of these compared at the end, but for some reason that slide's gone, so I'm just doing this here. Okay, so stopping this, whoopsies. Going back to here. So next up is to talk about, there is another thing that we can do to analyze histograms. So this is one way we can analyze histograms, is by talking about how they're skewed. But the next way to talk about histograms is to talk about this. It's to talk about spread. Now, both of these graphs are symmetrical, right? They're both, again, they don't look super duper symmetrical, especially this blue one on the left. But if we look at this blue on the left, its values range from about, its smallest value is about 543, and its largest value is up here at 11, okay? Whereas if we look at this one on the right, yeah, sure, this is symmetrical, but this one has a smallest value of about 1 and a largest value of about 15. Notice though that in both cases, the middle of the graph is at about 5, 6, is about here, roughly about 7.2, and this 1, 5, 6, 7, yeah, about maybe 7 or 8, you know. The middle of these graphs are at the same point, but they are both spread differently. And that's why I've got this picture of a melted ice cream, because when you melt an ice cream, it spreads out. We actually refer to this left one as a small spread. The values are very close together, whereas the one on the right, this is a large spread. The values are very far apart. So now, if I asked you guys, if I did something like, okay, let's look at the ages of people in year 11. Now, if I did the ages of people in year 11, that would be a very small spread. Like ultimately, there would be some 17-year-olds, there'd be some 16-year-olds, there'd be maybe even some like really like young 15-year-olds doing year 11. There might be some 18-year-olds doing year 11, but yeah, that's going to be the spread. You're not between 15 and 18, with the bulk of them being that 16, 17. You're not going to expect many 22-year-olds. You're not going to expect any 3-year-olds. So it's going to be a very short, small spread. If I asked you the amount of, if I did instead the amount of students in the age of students at a university course, that would be a bit more spread out. You would have some 20-year-olds, some 19-year-olds, some 18-year-olds, some 22-year-olds, some 23-year-olds, some 24-year-olds. You might have a 30-year-old, you might have a 45-year-old person that's doing it. So the values are spread out. So what I would like you guys to do is to jot this down. You don't have to obviously draw a picture as accurate as this. How you would probably draw a picture is like this. I would go like one like this. So that's what I refer to as a small spread. And a large spread, that would look more like this. Now you can have a large spread that's skewed, but in general, we're just sort of looking at the spread. How spread out is it? Is it really spread out? Does it cover a large range, or is it really small? In fact, that's one of the things we're talking about here. Is we're talking about range. We're talking about how spread something out is. When we talk about how spread something out is, we talk about what is the range. And that's when I first looked at the smallest value and the highest value, I'm actually talking about the range of the data, which is another way you can think about spread. I'm going to keep this up for another 30 seconds. And then I've got another slide. I think I've got one more way to analyze data. Maybe, I'm not sure. I can't. Yeah, we're going to talk about one sort of extra little bit here. If not, I'm going to have to draw my own slide. Okay, I'm going to change the slide now. One more last thing, one very, very last thing to talk about here with regards to spread is you can only really do this when you compare two different sets together. It's hard to talk about whether one is more spread out than the other when you don't know it. Also, with both of these, with spread and with skewing, you can only tell that a graph is skewed properly once you've turned it into a histogram. You can't really look at this data and tell me whether or not this is spread out. And it's very difficult to look at this data and say, oh yeah, it's skewed, because you really need to sort of actually plot it out before you can get a good idea of what's going on. So the last thing I wanted to show you guys was this. So this is now, this is the last idea. Now you might think, okay, well, he showed a skewed, which had a different, which is when it was squashed on one eye. He showed a spread when it's spread out. These two graphs look identical. What's the big deal here? Why are these two graphs unique? Well, the trick with these two graphs is, yeah, they actually look identical, I agree. But the trick here is this. The middle, the very center of this is between 5, 6, 7, and 8, is between 7 and 8. But the center of this one, 7 and 8 is down here. The center of this one is between 10, 11, 12, and 13. And this is a different way that you can refer to something. This is the last way to talk about, I guess, the information you can extract from a histogram, and that is to refer to the location. These two graphs have, these are the same histogram, but the location of the values have moved. Sometimes people refer this to as the center. That's another way you can refer to it as the center has moved. Where is the center of the graph? And so this is, I guess, the three ways that we can talk about histograms. So for this picture, if you guys are drawing pictures as well, I would just draw one that looks like this. I'm going to just do the same graph but looks like this. It's the same graph, but it's been moved to the right a fair bit. And that's what we refer to as location. There's not really much here to talk about, so I'm just going to leave that there like that. I'm going to give it about maybe 30 more seconds just to copy this down. If you are copying this down, if you're just looking at these slides and just, I'll copy it down later, or I'll look at the slides later and make my own notes, that's fine too. I'm just like giving those people that are taking notes diligently, giving them a chance to write things down. Okay, so let's cover the three things that I've just talked about. Write them down. We talked about these three things. We've talked about whether or not it's skewed, which is a measure of its shape. We've talked about its spread, and then we've also talked about its location. So these are the three things that we've talked about when it comes to sort of determining some information about a histogram. So the very last thing we're going to touch on, and I say last thing because I pretty much talked about everything that I want to talk about with histograms. This is a pretty big lesson, I know, so there's a lot of stuff to cover. I've been talking at you for about almost like an hour, so it's kind of bad as a teacher to do that, but we're almost done. Would be to look at this. So let's go have a look at this graph here. This is some heights. So the amount of people, maybe they're people, maybe they're not, maybe they're trees, who knows? Oh, it says people. So let's look at this histogram now. What we're going to do is we're going to do the opposite of what we did last time. instead of trying to take a histogram and get information from it, we're going to take a histogram and we're going to try and understand it. Is this graph skewed or symmetrical? What do you guys think? Do you guys think this is skewed or do you think it's symmetrical? Write in chat. I want to see 3 votes, maybe at least. Skewed? One person says skewed. What does everyone else think? If it is, yeah, okay. Yeah, one more vote. What do you guys think? Is it skewed or is it symmetrical? One more. What does someone else think? I want one more person. I've got 2 answers here. One from Emily, one from Anonymous. What's someone else say? Do you think it's skewed or do you think it's symmetrical? Give me a guess. Skewed. Okay, I've got 3 people saying skewed. 2 people saying skewed with a question mark. Oh, I've got one more. So yeah. So this is a. I would easily say this. I could easily say that this is actually a symmetrical graph, but I can sort of see that it might be a skewed graph too. If it is a skewed graph, it looks like it's going to be a lot easier to climb from the negative side rather than from the rather from the positive side. So let's call this negatively skewed. Now, if you're like concerned for this being a bit like difficult to tell, don't worry. If we ever give you guys a test question, it'll be very clear that it's negatively skewed or very clear that it's symmetrical. How many people are there between 150 and 155 centimeters? Well, we can figure that out. Here's 150, here's 155. There are 8 people. There are 8 people that are between 150 and 155 centimeters. How many people are taller than 155 centimeters? Who wants to tell me this one? This is actually, I'll put this open to chat. I want you guys to work this out. How many people are taller than 155? 4? Let's have a look. Yep, it is 4. The reason for that is we're looking for from 155 upwards. So there are 3 people here. There's 1 person here. So it's 4 people that are taller than 155. How many people are there in total? All right, so 831. We've got 6 people here. We've got 5 people here and 2 people here. Adding these up, I'm going to do some cheating here. 6 plus 3 plus 1 makes 10 because that's 4 plus 10 plus 8 plus 2 is 20, 25. But if you want to be a proper person, 2 plus 5 makes 7, 7 plus 3 makes 13, 13 plus 18 makes 21, 21 plus 3 makes 24, plus 1 is 25. I just combined numbers that added to 10 because it makes it easier to do maths. What percentage of people are taller than 155? Oh, great. Now they want a percentage. Well, we've got 4 people out of those 25 are taller than 155, which means we've got 8 people out of 50, which means we've got 16 under 100, so that's 16%. Or you can just go 4 divided by 25, multiplied by 100. But yeah, that's how you can work out, in this case, some interpreting here. Now, we haven't been asked any questions about the center or the spread, but that would require us to have 2 graphs to compare. So that's pretty much all that I had to teach you guys. So thanks for listening to this.